All right, so point slope version of the form of a line, the equation of a line, point slope form. I know when I was in high school, I like avoided it. I said, whatever you do, give me slope intercept because I don't quite feel comfortable with point slope. Well, point slope's actually easier to use than slope intercept in almost all cases. So let's take a look. The point slope form of the line is we have y, so the variable y minus the y coordinate of one of the point of a point that it goes through, and this is set equal to m times the x value, the variable x minus the x coordinate of that same point. So they use this subscript x1 and y1 to represent an actual point that this line is going through. So we have an example down here. So up here, you've got that same thing kind of written out. What is the equation of a line that has a slope of a -4 and passes through the point 7, 6? Well, if I were to use slope-intercept form, it actually would be quite a bit of algebra for me to do. Not a ton, but quite a bit. So it's quicker for me to write the equation of this one when they give me the slope and they give me a point. So they tell me it goes through 7, 6. So let me make a quick sketch of this. I like to make a quick sketch. Let's see. 1, 2, 3, 4, 5, 6, 7. 6 is up here, slope of -4. So from here, I would go down 4, 1, 2, 3, 4, over 1. 1, 2, 3, 4, over 1. So it's pretty steep. And if I had to guess at what the y-intercept was, it would be way up here, some big number, way, way, way bigger than 6. Okay, so that's my sketch. The point, they give us this x coordinate is x1 and the y coordinate is y1. Okay, so 6 is y1, 7 is x1. I can just plug those in. So I'm going to use this form up here, and I have y, so the variable y minus the y coordinate, almost done, equals m. Oh, m is -4. So -4 times x minus x1, which is 7. I'm done. Yeah, you're done. If you wanted to turn this into slope intercept form, you could. You would have to solve it for y. So I would add 6 to both sides, but I also need to distribute this -4. So we didn't have to do that for this problem, but if you wanted to, like for instance, you want to know what is this? What is that y-intercept up there? I can distribute my -4 and I get -4x plus 28 equals y minus 6. And now solving for y, I'm going to add 6 to both sides. So plus 6. So it looks like I get y equals -4x plus 34. So this form of the line, this y equals mx plus b form, the slope intercept form, does kind of give us that nice feature that's way up here at 34. Okay, nice. You should have the same slope. It doesn't matter which form of the equation of a line that you are writing the equation for. If the slope's -4, it better be -4 in every form of the version. Okay, so then we have, here's our second equation. I only did two equations because these are probably the most common you're going to get. What is the slope intercept? Oh, not slope intercept form, but what is the point slope form for the equation of a line that goes through these 2 points? So I'm going to draw this out. By the way, these points might look familiar to you. 3, 8. So 3, 8 is right about here. And 6, 5. Okay, 6, 5 is right around here. And we've got this line here. Looks like it's got a negative slope. Okay, so first, let's find that slope. And just a reminder, to find the slope, it's the change in y. So how much does my y value change by? We also call that the rise. So I started at 8, ended at 5. I'm looking just at the y coordinates. Started at 8, ended at 5. So I went down 3. Down 3. And my run, I looked just at the x coordinates. I started at 3, ended at 6. So I went up 3. And if you're going from left to right, the run is always going to be positive. Just like a pro tip there. So this slope here, slope equals -3, the rise over the run, -3 over 3, which is -1. So my slope is -1. I'm pretty much done. Well, I can take the coordinates of either point. I'm going to take this point here. The tricky thing is make sure you use the x and y coordinates of that same point. That's really the only tricky part here. So my y coordinate here is 8, so I have y minus 8 equals -1, that's my slope, times, and let's put this in parentheses, x minus 6. Sorry, x minus 3. One of the confusing things, and this is probably why I didn't like using it when I was in high school myself, is what if the x coordinate was -3? Well, then you have x minus -3. X minus -3 there. And I think that was the part that gave me kind of the, "Oh, I don't like it." But really, you're just going to take this and say, I'm subtracting a -3. Let me add the opposite. So this turns out to be x plus 3 if the x coordinate were -3, and y minus 8 equals -1 times x plus 3. Again, it wasn't in this case. Let's take this one. So we get y minus 5 equals -1 times x minus 6, and you're done. Don't put it in slope intercept form if you don't have to. You're done. All right, we'll get them.